It is really good to see that even Google has now focused on security related products, applications, and use cases with the help of large language models. As artificial intelligence continues to advance at rapid speed, and there is no doubt around that, so has its ability to unearth hidden security vulnerabilities in all types of software and applications. Every bug uncovered is an opportunity to patch and strengthen code. But as detection continues to improve, we also need to be prepared with new automated solutions that bolster our ability to fix those bugs. That, and I think this methodology can also be applicable to any other software application when it comes to patching and debugging the bugs. That is where Google in this research paper has released Secure AI Framework or SAIF. This Secure AI framework includes a fundamental pillar addressing the need to automate defenses to keep pace with new and existing threats. This paper, which you can see on your screen, is really full of nuggets around this patching and security aspects of large language models. It shares lessons from Google's experience leveraging AI to scale their ability to fix bugs, especially those found by sanitizers in C and C++, Java, and Go code. One of the highlights of this paper is the introduction of this AI powered pipeline to automate vulnerability fixing. By automating a pipeline to prompt large language models or LLMs in short to generate code fixes for human review, they have harnessed their Gemini model to successfully fix 15% of sanitizer bugs discovered during unit tests, resulting in hundreds of bugs patched. If you look at the steps involved, they are quite interesting. For example, the first step is finding bugs. The process of detecting and reproducing sanitizer bugs or vulnerabilities is environment specific, but for the purpose of this LLM pipeline, there are two main considerations. First, preserve all information from the test run, and then secondly, ensure the service can run easily reproducible tests, both to catch non-deterministic bugs that need multiple attempts and also that tests can be run without any error. Google is using detection service which is language agnostic, by the way. Second step is to reproduce and isolate the bugs because LLMs do not have infinite memory, which is also called as context length. So the prompt for the LLM is limited in length. That is why we need to isolate the specific code that needs fixing to create a concise prompt for the LLM. Third step is generating fixes with LLMs because it's not really worth spending a lot of time on prompt engineering for individual bugs in this context because the results wouldn't be significantly different given the effort and resources needed. That is where they need to use concise and to the point prompts. Fourth step is to test the LLM solution, and for that they needed an automated way to create commits from their generated output in order to run automated tests on modified code. LLMs, especially those not trained for coding, often add extraneous details to the code. While sometimes helpful, such as for commit messages, these details can complicate the process a lot. So that is where they have used few short prompting to give the LLM example of our desired output structure and request that generated code is enclosed by special symbols to help filter for the correct lines. In the fifth and final step, these tests and sanitizer checks are only considered as first step to address the possibility of hallucinations. Because currently an ML generated fix, even if it passes all of the tests, must be reviewed by humans, and that is very important. For additional safety, in this research paper they have employed a double human filter on top of automated analysis. In the first round, they rejected approximately 10 to 20% of the generated commit, and then in the second round, they also did more quality oriented filtration. Now, all in all, these results are really promising by this AI powered pipeline but still there is a lot of work to be done. And Google has said that in this paper that they are going to expand the capabilities to include multi-file fixes and also to integrate multiple bug sources into the pipeline. I'll drop the link to this really good paper in the video's description, and I will really urge you to read it out, because I think this is one of the best and very nicely written paper out there when it comes to this AI powered patching. I hope that you enjoyed it. If you did, please consider subscribing to the channel, and if you're already subscribed, please share it among your network. Thanks for watching.